Okay, the next thing we're going to talk about is an increasing and decreasing function. And so we're going to start off with some a definition here. We say f is increasing. Now the symbol we're going to use for increasing is that. And similarly, the symbol we're going to use for decreasing is an arrow. If we're going to, so increasing, we mean that. Decreasing, we're going to use that symbol. So a function is increasing on an interval and this may be any type of interval. So f is increasing on an interval if, and this is the requirement, for any x number 1 and x number 2 in the interval. Now, what does that mean? You're free to choose any two values in the interval. And let's assume that x1 is strictly less than x2. So we choose any two values in the interval. Let's assume x number 1 is smaller than x number 2. One of them needs to be smaller than the other. We'll call the smaller one x1. Then, what needs to happen is, in symbols, f of x1 must be less than f of x2. So the question is, can we understand what all these symbols mean? Well, I think if we draw the picture, it makes sense and it matches, it fits in with what we understand the notion of increasing and decreasing to be, even in the ordinary sense. So, suppose we have some sort of an interval here. It might be an open interval, it might be a closed interval, it might be an interval of infinite length. The specific interval is irrelevant. But suppose we have an interval. In this particular case, let's suppose I have A and B. It doesn't need to be a closed interval, it doesn't need to be a finite length interval, but let's just assume for this time we have interval AB. It says, for any two values in the interval, we are free to choose any two values in this interval. And so I'm going to call this one x number 1 and x number 2. Remember, I can choose these to be anywhere I like. The only requirement is we're going to have the lesser one be labeled x1. Then what that says is f of x1, so let's suppose here's f of x1, that's this distance, or this height, f of x1, must be strictly less than f of x2. Now, let's assume we have a function, the graph of which connects those two lines. Let's assume, just for our argument's sake, let's assume that's the graph of the function. And so what we're saying is f of x1 is less than f of x2. Let's suppose this is the graph over the entire interval. And so what we're saying is, roughly speaking, the graph is going uphill. As you go from left to right, you're getting higher and higher on the y-axis. Small x values correspond to small y values, and large x values correspond to large y values. Small goes to small, large goes to large. So that's the definition of an increasing function. Decreasing is defined similarly. It says, if f is decreasing, f is decreasing if for any x1 and x2 in the interval I, and again, let's assume that x1 is still less than x2, then this is x1, this is x2. Then, what we require is f of x1 is greater than f of x2. What does that mean? F of x1 is now the larger value. F of x2 is now the smaller value. and let's assume this is the graph, what that means is the curve is now going downhill. This must be true for every possible choice of x in the interval. So it matches our intuition. Increasing means the curve is going uphill. Decreasing means the curve is going downhill. Now, this official mathematics says x1 less than x2 implies f of x1 less than f of x2. In a little more friendly language, small x's go to small y's, large x's go to large y's. But here the relationship is reversed. x1 less than x2 implies f of x1 is greater than f of x2. Small values on the x-axis correspond to large values on the y-axis, and large values on the x-axis correspond to small values on the y-axis. So the official statement of increasing, decreasing has to do with these inequalities. But we can see that even though those statements look very technical, they actually describe what we understand to be, in the ordinary sense, what we mean when we say increasing, going uphill, decreasing, going downhill. So the next thing we're going to take a look at is, okay, how do we analyze the increasing and decreasing of a function? How can we determine where a function is increasing, where a function is decreasing? How can we find where that occurs? And the question is, can we get around having to do this little technical algebra here? It turns out, with the tools of the calculus, we can find these values and find those intervals of increase and decrease in a little bit more straightforward fashion.